Hello everyone, welcome back to my YouTube channel. I am Bhumikavi, pursuing my Computer Science and Engineering from Sri Venkateshwara College of Engineering, Bangalore. Today I am here to explain the topic like corrosion, its types and its control. Let's move on to the topic. Firstly, let us know what is corrosion. Corrosion is a natural process that converts a refined metal into a more chemically stable oxide. It is the gradual deterioration of materials, usually a metal, by chemical or electrochemical reaction with their environment. Let us discuss about types of corrosion. There are mainly two types of corrosion, that is dry corrosion, which is also known as chemical corrosion, and the second one is wet corrosion, which is also known as electrochemical corrosion. Let us know the definition of these two terms. Dry corrosion. This type of corrosion takes place due to direct chemical action of atmospheric gases and anhydrous liquids on the metal surface. Wet corrosion. This type of corrosion is due to the flow of electron from metal surface anodic area towards cathodic area through a conducting solution. Let us know about different types of wet corrosion. Wet corrosion is of two types. First one is differential metal corrosion and the second one is differential aeration corrosion. Differential metal corrosion. This type of corrosion occurs due to the difference in the electrode potential of metals on combining two different metals. For example, steel screws in brass and bronze equipment, lead tin solder around copper wire, steel pipe connected to copper plumbing. Let us consider another example. When we consider iron and copper in contact with each other in a corrosion media, since the iron lies I in electrochemical series than the copper, iron cuts as anode and undergoes corrosion protecting the copper. In order to prevent differential metal corrosion, both nut and bolt are made up of same metal. Differential aeration corrosion. When a metal is exposed to different oxygen or electrolyte concentration, it forms galvanic cell or oxygen concentration cell. This type of corrosion is known as differential aeration corrosion. Here, part of metal which is exposed to less oxygen concentration acts as anode and undergoes corrosion. The other part of metal which is exposed to higher oxygen concentration acts as cathode and it is protected. There are two types of differential aeration corrosion, namely waterline corrosion and pitting corrosion. Let us know some information about these two topics. Firstly, let us know about waterline corrosion. Let us consider iron rod dipped in electrolyte or water. Part of metal or iron rod contact with less oxygen concentration acts as anode and undergoes corrosion. Other part of metal above water line, which is ion contact with higher oxygen concentration, acts as cathode and it is protected or it is unaffected. For example, ship sailing on water and steel water tank. Let us move on to pitting corrosion. Deposition of impurities like dust, sand, drop of oil or water on the metal surface induces pitting corrosion. Part of metal covered by the impurities is in contact with less oxygen concentration compared to other part of the metal. Due to this uneven oxygen concentration cell is formed. The part of metal below the impurity which is in contact with less oxygen concentration acts as anode and undergoes corrosion by protecting the other part of the metal. Corrosion starts just beneath dust particles, resulting in formation of small hole known as pit. Since this type of corrosion results in formation of a pit, it is known as pitting corrosion. Once the pit is formed, rate of corrosion increases. For example, less aerated areas of machinery. Let us discuss about corrosion control. Corrosion can be controlled by the following three methods, that is metallic coating, anodizing and cathodic protection. For better understanding, let us consider an example in which a corroded steel screw is immersed in an acid solution and left as it is for few minutes. After few minutes, when we take out the screw out of the acid solution, we see that the screw is entirely free from rust, or the corrosion or the rust which was present on the surface of the screw is completely removed. Let us discuss about metallic coating. Firstly, let us know what is metallic coating. Deposition of metallic layer on the surface of base metal, that is the metal to be protected from corrosion, is known as metallic coating. There are mainly two examples of metallic coating, namely galvanization and tinning. Applications of metallic coating. Commonly, they are used to protect roofing sheets, wires, pipes, nails, bolts, buckets, etc. and they are also used in electrical appliances. Let us discuss about anodizing. Firstly, let us know what is anodizing. Anodizing is an electrochemical process in which the natural oxide layer existing on the surface is increased in thickness. As aluminium exists in the anodic side of the galvanic series, it forms oxide readily, which is corrosion resistant, hard, and abrasion resistance. In a simpler way, anodizing can be defined as the process of increasing thickness of oxide layer on passive metals artificially in acid medium is known as anodizing. Here is one example which is showing the anodizing of aluminium, where anode is the aluminium and graphite is considered as cathode, and the electrolyte used is sulfuric acid, and the voltage is around 40 volts and the temperature is about 35 degrees Celsius and the current density will be 10 to 20 milliampere per centimeter square. Let's discuss about cathodic protection. Cathodic protection is a technique used to control the corrosion of a metal surface by making it the cathodic side of an electrochemical cell. The simplest method to apply cathodic protection is by connecting the metal to be protected with another more easily corroded metal to act as the anode of the electrochemical cell. Thank you for watching. Please do like the video and subscribe to my YouTube channel.